Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we would be solving more problems using substitution method. If you haven't watched my previous video where I have explained substitution method, please do visit and see the video so that you would understand the entire process of substitution method. So before starting with the actual problem solving, I would just want to revise the steps that we are supposed to use in order to solve a pair of linear equations in two variables using substitution method. So there are four steps involved in it, out of which the first step is isolation, and we are supposed to isolate the variable x in the first equation. Then since it is step 2, that is why we are going to use, just to remember, this is a trick to remember, right? So step 2, we are going to use equation number 2, and step 2 is a very important step wherein we are going to actually substitute the value of x that we have got in step 1 in equation number 2. So step 2, take equation number 2 and instead of x, put the expression that you have got in step number 1. That is why first step is isolation, second step is substitution, third step is where after ending with your step number 2, wherein you would be getting the value of y. Now at the end of your step number 2, you are supposed to get, or you will surely get, the value for the second variable. So using that value for the second variable in step number, in the expression that you have got in step number 1, you will get the value for the first variable, that is x. And finally, fourth step is verification, where whatever resultant values you have got for the variables x and y, or whatever variables are given in your question, you just have to substitute those in both the equations and see whether your LHS comes out to be equal to your RHS or not. And since it is the verification step, you need to make it sure that whatever answer you have got in that, your LHS is equal to your RHS. If that is not the case, it means that you have done some calculation mistakes or error. So now let's start to solving the problems. So the question says that solve the given system of linear equations. Now what do you mean by given system? Meaning the two equations that are given to you. As the question says, we are supposed to solve, meaning we are supposed to find the answers, the values of x and y. Now since we are supposed to solve these equations and we know substitution method of solving the equations, hence we would be using the substitution method only in this case. So let's start. The equation says root 2x plus root 3y equals to 0 and root 3x minus root 8y equals to 0. Now let us again use the step-by-step approach. Once again, I would like to mention that while you are solving these problems in exam, you are not supposed to write down the steps. But yes, before going to the exam or while you are studying or practicing the problem, I would tell you, revise the steps again and again so that you would be able to recall the process. In that case, you just need to remember these steps, and whatever the steps tell you, you have to do accordingly. So step 1 says that you isolate your x in equation 1. So I won't be writing steps now, I would be just reciting them and I would be doing accordingly on the board. So I would be considering the first equation. So consider root 2x plus root 3y equals to 0. Now since I want to isolate x, so rest all the other terms are supposed to be sent on the right hand side of the equation. So root 2x would be equal to minus root 3y, because 0 minus root 3y would be minus root 3y. Now I would again send root 2 on the other side. So x ka value in this case would be root 3 upon root 2 times y. So this is your value for x. And this is your end of step number 1. Now, step number 2 says substitution, which means that whatever value you have got in step number 1, you are supposed to substitute in equation number 2 and mark this as star. Okay? Now, so substitute star in equation 2. This is your step number 2, and from here your step number 2 might go a little longer, because after substituting the value for x in equation number 2, you would be getting the value for y. So now here the magic happens. What is the magic? That your equation in two variables get transformed into equation in one variable, and that is due to the magic of substitution. So I would be considering equation number 2, which is root 3x minus root 8y equals to 0. Instead of x, now you would be substituting this value. So root 3 multiplied by root 3 upon root 2 y minus root 8y equals to 0. Now root 3 into root 3, so that is basically root 3 the whole square, and we know that square and square root gets cancelled. That is why root 3 into root 3 would be 3 root 2 y minus under root 8 y equals to 0. Now here if you see both of them, these are the like terms. We can say like we have the same variables over here. So can I take y common? If I take y common, then there would be 3 root 2 minus root 8 left inside the bracket. Now since I want to find the value for y, that is why rest other terms are supposed to be sent on the right hand side of the equation. So since this term which is there inside the bracket, it is in multiplication with y, when it goes on the other side, of course it would be divided with 0. So y in this case would now be equal to 0 upon 3 by root 2 minus root 8. We all know 0 upon anything is always 0. So we get y ka value as 0. Now this is the end of step number 2. In step number 2, after substituting this x into equation 2, you are supposed to get the value of y. Now your step number 3 begins, which says put y in step number 1. So wherever your step number 1 ends, okay, that particular equation may you have to substitute this value. So write substitute y equals to 0 in star, right? So what do we get? X equals to root 3 upon root 2 into y. So that is equal to root 3 upon root 2 times 0, that is equal to 0. So your x in this case is 0. So we got x as 0 and y as 0. Now let us verify. Verification is very important. I would be doing verification over here. So for verification, this is your step number 4. You are supposed to take the LHS. So write LHS equals to root 2 x plus root 3 y. We know that x is 0 and y is also 0. Anything multiplied by 0 is 0. So we get answer as 0, which is of course your RHS. Similarly, you have to do this again for the next equation. So consider again the LHS of the second equation. The second equation is root 3 times x minus root 8 times y. Again, instead of x, you are supposed to substitute 0, and instead of y, you are supposed to substitute 0. Anything into 0 is 0 again, and that is why you get answer as 0, which is equal to your RHS, and hence it is verified. So this is how you would solve the given system of linear equations using substitution method. Now let's move on to the next problem, next system of equations. So again, the question remains the same. You're supposed to solve the given pair of linear equations in two variables using substitution method. Let us start solving this problem. Now, if you look at both the equations, they are numbers only, but if you see, they look weird because you see decimal numbers as the coefficients for the variables, and even the constant terms are in decimal numbers only. And when you try to perform any arithmetic operations, or when you try to perform any calculations using any fractions or decimal numbers, it becomes quite complicated. So in this case, what we are going to do is, first we would try to simplify the question. Like yesterday we had, in the previous video we had used fractions. The question was given in terms of fractions and we tried simplifying it into normal whole numbers instead of fractions. Similarly, what we would do is we would try to simplify this question and we would try to get rid of the decimal numbers. Now, just like in a fraction we wanted to get rid of denominators, and that is why we took the LCM and then we shifted the denominator on the other side of the equation. Similarly, what we can do here is, first we would be converting these decimal numbers into fractions, and then we would be taking the LCM and or we would see what else can be done after this. So first step here would be writing down the decimal numbers into fractions. So we all know that 2 upon 1 can be written as 21 upon 10, and this is something that you have even learned in your lower standards. So if you have decimal ke baad just one number, then you can write that number as 21 upon 10. If it was 212, then you are supposed 2.12, then you can write it as 212 upon 100. So you just have to add those many number of zeros jitne aapke decimals ke baad numbers hote hain. So if there are 3 numbers, then the denominator would be 1000, and this is the simple fraction rules that you have been learning since your lower standards. So what we would be doing is, we would be using the same rule over here and rewriting the equations. Now here we are not going to do any kind of modification. There is no modification. This is simplification, meaning eventually the question would remain same. It's just that for your convenience, you're going to simplify both the equations. So 0 upon 2, 0.2 can be written as 2 by 10 x. Similarly, 3 by 10 y equals to 13 by 10. And likewise, you can write the second equation as 4 by 10 x plus 5 by 10 y equals to 23 by 10. Right? Now, this is like your step for simplification. Before moving on to these steps, I have even mentioned earlier also that if there is a need for simplification, then you would do it. And here there is a need for simplification, right? So now that we have converted the decimal numbers into fractions, let us try to get rid of the denominators. So if you see, these two, like the two terms have the same denominator. So can we write it as a common denominator? So now the equation becomes 2x plus 3y the whole upon 10 equals to 13 upon 10, and 4x plus 5y upon 10 is equal to 23 upon 10. Now here you have two fractions on either side of the equality sign or equal to sign, and both the denominators are same. So can we cancel them? We can cancel them. So now the resultant equations after simplification, the pair of linear equations is 2x plus 3y equals to 13 and 4x plus 5y equals to 23. Now, instead of taking this as your question becomes like this, and there is no change. This is just, you have simplified it and you have written the same number in different form, right? Now let's move on. We would be using the steps for the substitution method, and we would be solving the given system of linear equations. So step number 1 is, consider equation number 1. Again I'll tell you, step number 1 में equation 1 use होता है, step number 2 में equation 2 use होता है. So since we are doing step number 1, I would be considering equation 1, and after considering equation 1, my focus would be on the first variable only. So first step is restricted to first variable, first equation, etc. So now I would be isolating x in this case. So since I want to isolate x, I would be sending 3y on the other side. So that would be 13 minus 3y. Now x in this case would be equal to 13 minus 3y the whole divided by 2. Now this is your end of step number 1. Mark this as equation star. This is your equation 1 and this is your equation 2. Now step number 2 is substitution. Again, since this is step number 2, we would be using second equation and we would be getting the value for second variable, that is y. लेकिन कैसे मिलेगा? So for that you have to perform magic of substitution. We would be using x का value. So now consider the second equation, which is 4x plus 5y equals to 23. Substitute x in substitute star, you can say. So you can write this substitute star in equation 2, right? So wherever there is x, you are supposed to write 13 minus 3y upon 2 plus 5y equals to 23. Now here, earlier this equation was an equation in two variables. Now it has transformed into equation in one variable. Here if you see this particular term which is there, I'm talking about this term, it is in multiplication with 4. So can I reduce 2 and 4? I can reduce it. 2 ones are 2, 2 twos are 4. So now the equation becomes 2 multiplied by 13 minus 3y plus 5y equals to 23. Now multiply 2 with each term inside the bracket. So we get 2 into 13 is 26. Minus 2 into 3 is 6y plus 5y equals to 23. 26 minus 6y plus 5y equals to 23. So I would be minus 6y plus 5y would be equal to minus y. Hence I would be writing 26 minus y equals to 23. Now I would be sending 26 on the other side. So minus y would be 23 minus 26. Hence minus y would be equal to 23 minus 26 is minus 3. Minus and minus gets cancelled. You get y as 3. Now you have got y as 3. This is your end of step number 2. Now step number 3 is whatever y you have got in your step number 2, you are supposed to substitute it in your step number 1 ka equation. I'm not talking about equation 1. Whatever equation or expression you have got in step number 1, उसमें आपको y का value substitute करना है. So you're going to write substitute y equals to 3 in star. So your x in this case would be equal to 13 minus 3 into 3 upon 2, which is 13 minus 9 upon 2, and 13 minus 9 in this case is 4 upon 2, so that is 2. So x in this case is 2. Now it's the time for verification. So let us do the verification. Step number 4. I'm going to consider the LHS of equation 1. So that's 2x plus 3y. I know that 2 and x ka value is 2, whereas y ka value in this case is 3. So I get 4 plus 9 and that is equal to 13. 2 into 2 is 4, 3 into 3 is 9, 9 plus 4 is 13, and that is exactly what your RHS is. So here if you see equation number 1 में अपन को मिला कि LHS is equal to your RHS. Similarly, again consider LHS of equation number 2, which is 4x plus 5y. 4 multiplied by x का value is 2, y का value is 3. 4 2s are 8, 5 3s are 15, and 15 plus 8 is 23, which is of course equal to your RHS. So this is the step which is like the most easiest step, in which you just have to substitute the value and see whether you get your LHS equal to RHS or not. Since I get LHS equals to RHS in both the cases, hence I'm pretty much confident that my answer is correct, and hence I would write hence verified. if at all you don't get this, it means that you have done a big mistake in your calculations, and that is why you cannot write hence verified at the end of the problem. You need to recheck, revisit your problem and see what has gone wrong with the solving part of it. So students, with this we come to the end of today's class, and in today's class we solved two problems using substitution method. If you see, the uniqueness in both these problems was that here the equations or the solutions that we got were x equals to 0 and y equals to 0. And here the question was a bit tricky, wherein you had to first simplify the question and then move on to the normal substitution method ka solving part. So our agenda for today is completed, and in the next video we would be solving more problems using the substitution method. So stay tuned. Till then, thank you.